Okay, some review that you have to know how to do before we can handle the quadratics in chapter 7. That's what you're doing now is quadratics. That times that, 12x squared, because the x and the x make an x squared, minus 15x. This one here, this one's a classic. If you can't do this one, well, anybody can make a dumb mistake, but if you had no idea how to do it, that's a very scary thing. Outside and inside minus 2x, last is minus 15. Okay, this one. This one you might just do out like normal, but you might also notice, ooh, it's one of those special ones where the outside and the inside cancel. So this is x squared minus 49. You can just go right to it right off the bat. All right. The outside and the inside do cancel if you did it the first outside and inside last way. And this one, you need to be beaten with a stick if you said the answer was that. I have a stick. All right. All right, so I knew there'd be a few. It's not just one person, I know it. It's like this, x plus 3 and x plus 3. That's how you square something, is times it by itself, and you forget to do the outside and the inside sometimes. X squared plus 6x plus 9. Raise your hand if you had that one right the first time. Okay, good. Moving on. What is a quadratic? A quadratic has a squared in it, and when you graph them, they will have parabolas. Now they can have an extra term like this, but they don't have to. They can just be plain old y equals x squared. That's a parabola too, and that's also quadratic. Anything that's got a little squared as its biggest power, its biggest degree, that's a quadratic. All right, so we have quadratics sometimes are written like this, y equals 3x squared plus 2x plus 5. The nice part about this is it has a and b and c. So that helps you do the quadratic formula. Remember that one? X equals negative b plus or minus square root b squared minus 4ac all over 2a. All right. This form is a little different, but it helps in different ways. Here's an example of one. Okay, and you've seen this before. Just ignore the green stuff for a second. You've seen this kind of equation before. It's a parabola because it's squared, right? And it's been moved which way? So it's a parabola. It's been moved right 3. And how about this? Up 5. And the last thing is, this is a stretch. Which way? Up. Stretched up. It's taller. It's twice as tall, to be exact. So here's a parabola. Here's the parent one. And if it's been taken and moved 3 to the right and up 5, and then twice as tall, from there it would just mean stretched. It's like skinnier and taller. All right, that's kind of what it would look like. But here's the main point of today. This is called vertex form. Can you think of why it would be called vertex form? Because maybe it has a vertex in it. This spot right here is special. 3, 5 is this spot right here. There's only one spot on a parabola that's really special if you think about it. Know what I'm talking about? I mean, all the other points on a parabola are just points that are along the way, but there's only one special spot, the spot where it changes direction. Stops going up, starts going down. Or okay, so one of my favorite sayings that you don't say to little kids, but you are all special, just like everybody else. Okay, but anyway, this parabola, all the points on it are all on the parabola, but really, truly, only one of them is special because it's the spot where it makes its turn. Okay, so in a parabola, this is that spot. And notice I used the opposite of this one because it's always counterintuitive on the inside, remember? All right, so if sometimes I feel like this one's a little too early. I want to do one more thing with this first before I get to that reading a graph deal. So that has a special spot built right into it. What's the special spot? 5, 15. If I wanted to graph this parabola, I could do it the long, slow, but always works way and get the XY chart. Or I could go like this. Over 5, up 15. Okay, and there's a dot, and that's the bottom of my parabola, right? And from there, I just go over 1, up 1, over 1, up 1 this way. And then go over 2 and up how far? Over 2, up 4, over 2, up 4, See what I'm talking about? You can graph your parabola from this really easy if you know that that spot is the vertex. All right, so here's another one. What is the special place? 7, 2. Now, I know you might be thinking that negative messes it up. It doesn't. What does that tell me about my parabola? This spot right here is the what? The vertex, the only special place on the whole parabola. And think about it now. This is not a normal parabola anymore because of this. It's an upside down parabola. So it's, what could you say about 7, 2? It is a parabola. It's just, oh, rats. I meant squared that whole time. Sorry about that. I wasn't trying to confuse you with that. All right, so then I, from here, can make my parabola. It's an upside down parabola. That's what that negative does. All right. So, moving on. Here's one. What is the vertex? 3, -7. And if I want to change this to general form, which is a really typical thing, in other words, this is one form of the equation, but couldn't I write it somehow like this? Yes, I could. Know what A, B, and C are? And it's really easy. Generally, to get general form, you just multiply it out. Whatever it takes. Now, they don't all need FOIL. This one needs FOIL, though. Okay, so then here's the common mistake not to make. Oh, x squared plus 9. No, it's wrong. You got to do that first outside inside last thing. So x minus 3, and then minus 7. Now, some people get confused on what order. Just follow the normal order of operations. That's all a big multiply problem. So it has to be first. Once you're done with that, then you can do the minus 7. Would you please do that right now and figure out what you think the answer to this one is? I got to keep you involved. If I let you drift, you might like start playing calculator games or dreaming about your favorite place in the world. How many of you have a favorite place in the world? I have a happy place. You should have a happy place. I mean, just in case you're ever tortured or something, you need to have a happy place that you can kind of go to in your mind. My happy place is in Kauai, and I visited this place. There's a beach in Kauai that's at the end of this long road. So here's the island of Kauai, and there's a road that starts over here, somewhere like here, and goes all the way around, and then the northern part of Kauai and up in here gets super rocky, so the road stops. So here's these huge mountains here, and right there is a beach at the end there called Ka Beach. Right there. And it's the best spot in the world. Beautiful. You can snorkel there. There's all kinds of big, huge waves crashing in. You can look down at these mountains from the beach, and you can see all these mountains as you look down there. It's called the Nepali Coast. And there's a hiking trails back up in there where you can like hike back in 2 days with a backpack and like camp in there. That's one of my things I got to do in my life list. So anyway, that's my happy place. Hopefully I never get tortured to need my happy place, but I'm still happy. That I have a happy place. Here we go. Y equals x squared minus 6x plus 9 minus 7, and then these guys can go together. Final answer, x squared minus 6x plus 2. Raise your hand if you had that. All right, now, I want you to check your paper very carefully. How many of you, be honest, forgot the y equals at the beginning? Be honest. All right, it's normally 4, 5, 6, 7. All right, that is an important mistake because this is not an equation. I just want to make sure you understand that. If you write that on the test, I have to lose half a point for it because it's not an equation. An equation needs an equal sign and something on both sides of it. That's an equation now. Okay, so don't forget that. I hate to lose half points. They add up. All right, this one looks like it's a vertex form, but that 5's in a weird spot. Can I just move it over there? Sure, but the common mistake is people will move it over there and say minus 5 and get rid of it like that. Can't do that. What can you do? You can move the 5, but what has to stay where it is? The negative has to stay. And you say y equals negative x plus 2 squared, and then I can move the 5 like that, because that negative is not attached to that 5. That negative is attached to the x, or the parenthesis here. Think of it as a -1 that's being multiplied right there. Okay, so now this one, what's its vertex? Don't say 2 comma 5. -2 comma 5. Good. Okay, so now if I had to graph this thing, I would start at -2 comma 5. And is this parabola go up like a normal like U shape, or is it more like a mountain shape? Mountain, so it goes like that, and there's my parabola. Now, that's not what they asked for, though. They asked for general form. So generally, you just multiply it out. So to multiply this thing out, I just got to remember to do that first in the order of operations. Next, after squaring, after exponents, comes that, which is a multiply by -1. And the last thing you do is add 5. Okay? When I'm multiplying everything by -1, I'm just changing everything's sign. Do I change this guy's sign? No. That -1 is not being multiplied by the 5. So, to start with, you do the inside here, which is this part squared. Can you do that in your head? X squared plus 4x plus 4. And then, I have plus 5 out there. Then I multiply everything by -1, which changes everything's sign. -x squared minus 4x minus 4, and then a plus 5. And then final answer, -x squared minus 4x plus 1. And what's wrong? Why would I lose half a point? Y equals. Okay, there it is. Okay, that's how you change from vertex form, which has a vertex buried in it, into general form, which the nice part about general form is it has an A and a B and a C. So you'd be able to use quadratic formula on it, and that's just generally the form that you'll see on a test more often is general form. All right, so if you had to do this one, just tell me what would I do first to get general form. Generally, you just what? Multiply it. So this squared would be first. After I'm done with that, what happens next? Multiply by 2, and the last thing you do, add 3. That's all there is to it. Okay, on this type of a problem, the typical homework problem today looks like this, and they say, what is this equation in general form? So first of all, I multiply it all out. So I do 2 times x plus 1, x plus 1. Remember, do the x plus 1 squared first because it was a squared. Then times it by 2, and then at the end, you do the subtract 2. Once I got that all multiplied out, I'll have general form. The vertex. The vertex is really easy. It's just buried in the problem. It's right there, and don't say 1, -2, -1, -2. Then is it a maximum or a minimum? Well, I'm looking at this, and I don't see any negative out in front. That means it's a normal shaped parabola. Okay, so then that means that the number at the bottom, if it's the lowest spot, what do you think we call it? The minimum. If you're at the top of a parabola like this, then that's called a maximum. All right. And the last thing is that kids find tricky is find f of 1. All right, well, it's really not that hard. Have you seen f of x written a lot? That means that they basically just said that x was 1. So by saying f of 1, they're saying x is 1. So stick in 1 for x, and then figure out what you get. And you'll have y equals whatever. And isn't y the same thing as f of x? Yeah. So basically, we're trying to stick in x is 1 and figure out what y is. Now, you could look at it on the picture if you want, or you could just stick the 1 in. It's the easiest way. 1 plus 1 is 2. 2 squared is 4. 4 times the 2 makes 8. 8 minus the 2 would make 6. So this answer is 6. So this answer is 6. Just stick the 1 in. Now, if you wanted to, you could look on your graph and find where x is 1. See, this is where x is 1 along here. And let's say that your graph looked like this. You could say, oh, the answer is right there. It's the y value. But so let's actually graph this one real quick. It won't be hard because it's in vertex form. So the vertex is -1, -2. So I can go to -1, -2. There's my vertex. Does this parabola go up like a mountain or like a valley? Which this one's like a valley. So then instead of over 1, up 1, this is my normal parabola, and I can see a lot of you doing this as a mistake answer. Okay, that's a normal looking parabola. Why is this one not normal? Stretched twice as tall. So instead of going over 1 and up 1, for that red point there, I'm going to go over 1 and up 2. Instead of going over 2 and up 4, I'm going to go over 2 and up 8. And instead of going over 1 and up 1, I'm going to go over 1 up 2. And same thing here. And now I can connect these little puppies. See how it's skinnier than the red one was? All right. So that's my graph of it. Now if I wanted to find f of 1, that means basically that I should have a 6 over 1 and up 1, 2, 3, 4, 5, 6. Look at that. I had a dot right there. So I could have found my answer of 6 by looking at the graph too. Okay, but on these I really think it's easiest to just say, oh, they're telling me x is 1. Stick in a 1 in the equation and figure out what the answer is. All right, now for your class, especially because we don't have much time because of the news show, I'm going to just jump right into the worksheet and do the first one with you. So you can put away your notes, and here comes your worksheet. I'm going to leave the recording on for the first example problem on the worksheet. The worksheet is called Vertex Form to General Form. Hand it back rapido, por favor. Keep it moving. Okay. Very first question says f of x equals x plus 2 squared. And then the first thing you have is a graph, which is sort of assuming you're going to graph it, and you are. So it's really pretty easy. You take a normal parabola and you move it where? Left 2. So here's my normal parabola, where I go over 1 up 1, over 1 up 1, over 2 up 4, over 2 up 4. And then I just got to move that whole thing left 2. So take it, move it left 2 spots. I'm going to get rid of my little earlier dots. Okay, here's my little picture. Next thing it says is DEFC. That means a description of what happened. What happened? It went left 2. Done. That's all I got to say for the description. Next thing is gen. That stands for general form. So generally, you just multiply it out. Don't say x squared plus 4. What is it? Y equals x squared plus 4x plus 4. Because remember, you'd have to split this into 2 of those and then multiply it out. There's your general form. And the last thing is f of negative 3. Okay, f of negative 3. What did they just tell me? They told me x was negative 3. And if they told me x is negative 3, I can either stick it in here or I can look at my picture. I prefer sticking it in here. Negative 3 plus 2 makes negative 1. What's negative 1 squared? Positive 1. Equals 1. And done. Now, I could have gone over here and found that it was right there. If I stuck in negative 3, I'd get 1, and it would be still the right answer, but I think it's easiest to just stick it in the equation. Okay? That's how you do this kind.